Hi, and welcome to this instructional video for the Systematic Multiverse Analysis Registration Tool. As multiverse analysis aims to reduce the uncertainty introduced by data processing and analytical variation, it's important that the decision-making process to construct the multiverse is documented transparently. This app was developed to support this process across multiple scientific disciplines. In this video, we will walk through the app step by step, and I'll explain how it works so that you can document your multiverse analysis in a systematic and transparent way. Upon opening the app, you will land at the welcome page, where you can read background information on why this app may be useful for you and its intended purpose. Along the top panel, the app is organised into two overarching stages of multiverse construction. Multiverse 1.0 provides a stepwise procedure to define a defensible multiverse of pipelines, whereas Multiverse 2.0 guides you through refining Multiverse 1.0 into what has been termed a principled multiverse, where only pipelines assessed as equivalent on a specific criterion are included. In this video, we're going to walk through each of these sections. If you click on the Start tab, you will find functions that organise and save your progress. First, you should enter a username that will be used as a unique identifier for your multiverse. For the purpose of this video, we will use example. Additionally, throughout the app, there are many opportunities for you to export the progress that you have made until that point. These files can then be imported back into the app at a later time. You can import your exported files in this field here, which will regenerate your progress, allowing you to continue where you left off. When you're ready to begin defining your multiverse of pipelines, you can select Multiverse 1.0 from the top panel, and you will see a series of tabs that should be followed in sequential order. So we start with the first step, which is 1A, define the multiverse space. Within tab 1A, you will first be asked to enter some details about the results that you intend to report. This consists of 3 text boxes, where you can enter your planned method to descriptively analyse the multiverse of results, to inferentially analyse the multiverse of results if applicable, and how you will handle multiple comparisons if applicable. Throughout the app, hovering over the blue question marks will provide further explanations to help you. In this example, we will say that we will compute a specification curve and report the distribution of effect sizes. Next, we move on to specify the scope. Multiple defensible options can arise at decision nodes throughout the entire workflow, including measurement, data processing, model specification, and estimation methods. A multiverse analysis can be focused on reporting robustness to one of these stages in particular, such as data processing, or it can span multiple stages, for example, reporting robustness to data processing and model specification variability. In this section, you should select the stages of your workflow where you will consider the alternative defensible options for your research question, study design, and data. If you are unsure what each of these labels represent, you can hover over the question mark for a definition. It may be the case that your multiverse analysis has a narrower focus, reporting robustness to only 1 or 2 specification decisions within one of these stages. When your scope does not fit exactly into one of these categories, you can provide further information in the text boxes provided. For example, if I want to assess robustness of an effect to outlier definition and outlier handling in particular, and not the entire data processing stage, I would select data processing, because these decision nodes fall within that stage, and I would specify in the text box that I intend to focus on those 2 decision nodes in particular. So I would write outlier definition and outlier handling. Further examples are provided at the top of this tab to guide you with this stage. Next, we will specify which method we will use to gather all of the potentially defensible options available within our specified scope. You may look for potential defensible options in the published literature, from your own expertise, in collaboration with other experts, through crowdsourcing, or through another method.
The method used can influence the pool of options that you sample and later consider for defensibility, so this should be documented. Here you can select one or more options that you will use, or if you intend to take a different approach that is not included here, you can select Other and specify it in the text box. For this example, we can select Expertise and specify Single Expert. This makes it clear to readers of your multiverse analysis which space the decision nodes and options were extracted from to be considered for defensibility. Scrolling down, we are asked to list all decision nodes and options that are possible within the specified scope using the specified method. Here it does not matter whether or not you believe that the decision nodes and options are defensible, only that they exist in the field and appeared within your search. You will classify defensibility at the next step. The reader of your multiverse analysis should be able to see which decision nodes and options were considered for defensibility, including those that were considered but deemed indefensible. Then it is clear whether any options not included in your final reported multiverse analysis were overlooked, or whether they were actually considered but evaluated as indefensible for the context of your analysis, for a reason that you will specify later. This helps readers and you to identify potential bias in the final multiverse and enhances transparency in the decision-making procedure. Here, node refers to a decision node in the pipeline. If we click on it, we can assign a label to that node. Using our example, this will be outlier definition. Clear and concise labeling is essential for the following steps. Then you should add all options that are available within this decision node, regardless of defensibility. For example, plus minus 3 standard deviations around the group mean, and we would continue to add options until this step is complete. And for simplicity in our example, I'll just label the rest 1B, 1C and 1D. However, you should provide clear and concise names that describe what is done to the data, as in the first example. Once you've finished adding all of the options for the specified decision node, you can click on Done, and you will see that a visualization appears on the right-hand side of the window as an individual network for each node, and this helps you to keep track of what has and has not been added. We can add another node by selecting Add Node, and we open it up in the same way. You can provide the label and add all of the options. Again, when we've finished, we can click Done, and we see this has now been added to our multiverse. This process is repeated until you have entered all potential options for all potential decision nodes within your specified scope. If there will be a decision node in your pipeline that does not have more than one option, you should still enter it here, because then adding the node and that one option allows it to be added to a pipeline in a later step. Once you have finished, check the figure to ensure that everything is there, and then you can move on to the next step. The next step of the procedure is 1B, Define Defensibility. Here, all decision nodes that you created in the previous step are displayed along the left side of the window. If you click on a node, you will see all of the options that are assigned to that node. Again, on the right-hand side, you will see the visualization of each node and its options as individual networks. Within this step of the procedure, you should go through each decision node and option and classify it as either defensible or indefensible. Each option at each decision node is to be considered independently. For example, perhaps an option is defensible in some scenarios, maybe depending on the other options selected earlier in the pipeline. However, if an option is defensible in any scenario for your specific multiverse, you should classify it here as defensible, because we will define the defensible combinations of options in the next step. You can classify a node or option as defensible or indefensible by using the radio buttons underneath it. Once classified, the node or option is automatically color-coded in the visualization. green for defensible, and red for indefensible. This provides you with a summary of your decisions, and you can always go back and correct any mistakes that you may have made. Now we will go through all options and set them to defensible or indefensible. When marking an option as indefensible, you should provide a justification in the respective text box so that readers of your multiverse analysis can understand and evaluate the decision that you've made. Here you would add a specific reason for why you believe that this option or decision node is always indefensible for your multiverse analysis. Finally, check that the colour code in the figure matches the classifications that you intended, and that no mistakes have been made. Once complete, you can proceed to the next step, and all of the nodes and options that are classified as defensible here will be carried forward. Moving on to step 1C, create defensible pipelines from the defensible decision nodes and options that you classified, so set to green, in the previous tab. This can be completed in one of two ways. One option is to manually build each individual pipeline from your created pool of defensible options. This construction approach is most useful when your multiverse is relatively small, or when only a specific subset of pipelines needs to be built, such as those identified in a systematic literature review. Alternatively, the app can generate for you automatically the Cartesian product of all defensible options across decision nodes, followed by refinement. This automated construction approach is more efficient when your multiverse is large, as it allows you to start with the complete set of possible pipelines and then remove or exclude those that are not relevant. First, we will explore the manual construction approach. Start by selecting New Pipeline, and all of your defensible decision nodes and options will be displayed in a box on the left-hand side, and an empty canvas will be displayed on the right-hand side. Taking one pipeline at a time, drag and drop the decision nodes and options into the pipeline box in the order that they will be applied. While doing this, you should first select the decision node, followed by the option at that node. The node name should always precede the option name, because option labels could be fitting for more than one node. In this way, we are clear which decision node is to be executed at this location in the sequence. You will notice that only the nodes and options classified as defensible appear in this step, so options that were marked as indefensible in the previous step will not be available. We can create a two-step pipeline as an example. You can follow the construction of your pipeline visually on the right-hand side of the window, and you can change the sequence of the options by dragging and dropping within the canvas box. Once your pipeline is complete, click Save Pipeline, and the pipeline will be saved. You can return to it later if you wish to amend it by clicking Save Pipeline again. It will overwrite what constitutes that pipeline. When you are ready to create the next pipeline, click New Pipeline and repeat the procedure. This time, a different option at decision node 1 may be defensively combined with the same option at decision node 2, so we would enter this sequence for the second pipeline. This process is repeated until you have constructed all defensible pipelines from your decision nodes and options. To save time, it is possible to copy and paste chunks from previous pipelines into new pipelines. This is especially helpful for long pipelines of multiple decision nodes where the same string of options can be repeated with minor changes. The second option is to automatically generate the Cartesian product of all defensible options across decision nodes. Here there are two generations available. If you do not tick this box labelled Advanced Include All Node Permutations, the order of decision nodes will be fixed as the order that they were entered in tab 1b, and the Cartesian product that is automatically generated will be for all combinations of options in this fixed order of decision nodes. You can then refine this by removing individual pipelines that are indefensible. Alternatively, if you wish to include different orders of decision nodes, then you can tick this box, which will automatically generate the Cartesian product of all options across all decision nodes, across all possible combinations of decision node orders. And a warning box will appear to let you know that this could take a while to process. Once complete, you can refine this multiverse to only the decision node sequences that are defensible by either removing all pipelines that begin with a certain node, or by removing all pipelines that contain specific two-node sequences for when it's never defensible that a certain node comes before another certain node. This process can be repeated until the multiverse that remains is defensible. Once you have completed the construction and refinement of pipelines, you can proceed to step 1D, where you can review and export your Multiverse 1.0. In this step, a drop-down menu lists all pipelines constructed in the previous step. Selecting a pipeline from the list will display the sequence of options in that pipeline as both a table and a figure. This allows you to review the completeness of your pipeline, and you can, if you wish, check this for all of the pipelines that you've constructed. To help you to reflect on potential imbalances in your multiverse, you are also given a frequency count of each option across all constructed pipelines. This feature can help to identify whether certain options are unintentionally overrepresented, which could bias the interpretation of robustness. When you are ready to confirm the final multiverse of pipelines, you can select Export Construction, and this will download to your computer a zip file containing all of the information that you have input from tabs 1A to 1C, with each section of information in a dedicated CSV file. Additionally, you can scroll down and click on the Download Preprocessing Documentation button, which will generate a PDF file summarizing all of the information that you have entered across all of the steps and provide a visualization and table of each pipeline. To ensure compatibility with Step 2A of Multiverse 2.0, you should keep a version of the folder structure and file names that remain unchanged. When you have exported your documentation, Multiverse 1.0 is complete. Congratulations! Multiverse 2.0 refines the set of defensible pipelines that you identified in Multiverse 1.0 into a principled multiverse based on user-defined equivalence criteria and thresholds, and a data-driven assessment performed on either a subset of participants or simulated data. Pipelines that produce a value of the equivalence criterion within the specified threshold are classified as equivalent, while those that produce a value outside of the threshold are classified as non-equivalent, and only pipelines classified as equivalent are included in the principled Multiverse 2.0. The first step to achieve this is to specify the three decisions that define equivalence. First, the equivalence criterion should be specified. The previous literature suggests equivalence in terms of validity, testing for the same effect, or estimating the effect with comparable precision, but the criterion is not limited to these. Here, you should specify the exact metric that you will calculate across all Multiverse 1.0 pipelines to assess equivalence. For the purpose of this example, we will use the standardized measurement error. Second, you should specify the threshold for equivalence on this criterion. This could be a point threshold where all values above or below a point are considered equivalent, or it could be an interval of values. You should define here what best fits your equivalence criterion, and you should define it here before assessing your pipelines. For this example, we can say that all pipelines that result in a standardized measurement error of less than 0.2 will be deemed equivalent. You should select the criterion and threshold that makes the most sense for your multiverse analysis. Third, you should state whether you will perform the equivalence assessment on a subset of the final sample of participants or on simulated data, or both. If using a subset of the empirical data, if you have a fairly large multiverse analysis, running the full multiverse on the full sample of participants may not be practical, so you can specify in the accompanying box the proportion of the final sample of participants to be used for the equivalence assessment. And we can imagine a high-powered experiment with a large sample size and say, in our example, 10%. When simulation, or both, is selected, then users are prompted to provide a link to the relevant code or documentation that defines the simulated dataset. At this stage, you should now go to your preferred statistical analysis software and calculate the equivalence assessment that you have specified here, obtaining one value for each pipeline. It's helpful to keep the pipeline indices that are used within the app the same in the statistical software to avoid confusion. Once you have calculated this equivalence assessment, return to the app because then you're ready to complete the next part, which is to enter the results for each pipeline. Once you have computed the equivalence assessment, you can come back to the app and you will see a drop-down list of all pipelines constructed in Multiverse 1.0. Selecting one pipeline at a time, you should review the table and the visualization to check that it matches the pipeline for which you are about to enter a result. Once you've checked that it matches, you can enter the value resulting from this pipeline in the text box provided, and based on whether or not it is within or outside the threshold that you defined earlier, you can class this as a type E or type N for equivalent and non-equivalent. For example, let's say that pipeline 1 resulted in a standardized measurement error of 0.18. We would type 0.18 into the box, and because this value is below our predefined threshold, we would select type E to classify this pipeline as equivalent. We would then move through all of the pipelines doing the same thing. So we would check pipeline 2 to ensure that it matches what we computed in the statistical software, and we would enter the result for that pipeline in the specified box and classify it as either equivalent or non-equivalent, depending on whether the value falls within our predefined threshold. If we see that a pipeline exceeds our threshold for equivalence, we will classify it as type N, and this would then be removed from our Multiverse 2.0. All responses are saved automatically, and when you are finished, you can scroll up and move on to the next step. Now we reach the final step, view your principled multiverse. Here you can view all of the pipelines that were classed as equivalent. To extract the Multiverse 2.0, scroll down and click Download your principled multiverse PDF. This, as well as the documentation downloaded at the end of Multiverse 1.0, can be uploaded as part of your pre-registration or as supplementary material to your published multiverse analysis.
And that brings us to the end of the walkthrough. If you have any questions, feedback, or suggestions for future development, then we encourage you to reach out to either me or one of the co-authors via email or contribute to the GitHub repository. We would like to thank the DFG Special Priority Programme MetaRep for funding the project, and thank you for listening. We hope that the systematic multiverse analysis registration tool helps you to define your multiverse and contributes to a transparent and reproducible science.